Hello, budding chemistry scholars. In the next couple of minutes, we're going to go over 4 very important, pretty simple, but very important vocabulary words that we're going to be using throughout the year. So please pay close attention, but you don't have to write everything you see down. I will be very specific about what you need to have in your notes and what you need to write down. But do pay attention, and we will go through this as quickly as we can. What we're talking about is measurement. And so you can pause the video right now and take a look at these 2 definitions that I took out of a dictionary for the word measure, and compare the 2 definitions. And I want you to look at the statements at the bottom and decide which definition is the correct one to show how the word measure is being used in that sentence. So pause, take a look at those. So if you look at those, we're talking about the first one is really looking at taking measurements using some kind of a piece of equipment, and with that we would end up with a number. Okay. The second one, it doesn't refer to equipment or size or length or a quantity. It's talking about measuring, and it doesn't seem like there's numbers involved there. So I want you to kind of make a note of that. But when we observe the things around us, we are really measuring. And so this word measure can be used in a couple of ways. If you look at number 1, a cup of sugar for the punch, measuring 1 cup, that would be the first example of measure, because you're finding out the size of something, and it's going to have a number, right? 1. Number 2, you can't measure a school by their building. Well, that means you can't make a judgment about that school and what's going on there by just looking at the building. So that's referring to the second definition, where you're assessing something, you're assessing the quality. How great is that school? The building itself isn't going to be enough to talk about what's going on there. So measurement is really what we're talking about here, and as we measure in the laboratory, we need to be really careful about understanding the difference between an inference and a measurement. And a measurement is the same thing as an observation. When we talk about measurements, we think about in lab, we're going to write down what we measure. But really, measurements are an observation that we pay attention to, and we write them down in our lab book as our data, as we collect that data. So we have an inference and an observation, and we need to know the difference. So the first definitions you're going to see, you don't need to write those down. I want you to be able to look at formal definitions, but then I will show you the most easy to remember, the simplest definition that I can, but I always want to encourage you to be able to read the same information at different levels of academic vocabulary, at different levels of academic text. So I'll often show you a more difficult definition, but then for us to come up with a quick way to memorize something, we always want to pare that down to the simplest definition that we can work with. So here for an observation, it says it's an act of making and recording a measurement, or the observation could be the actual fact that we learned. Sometimes somebody says, well, I made an observation, and my observation was that you weren't there when I thought you were going to be there, or that, I don't know, some kind of a thing like, my observation would be that somebody let the dog on the couch because I'm observing hair on the couch, and maybe that's a situation where the dog's not supposed to be on that couch. So the observation could be that fact that we saw. An inference is different. An inference is the conclusion that's reached on the basis of the evidence and the reasoning. So in that scenario, the conclusion is an inference to say, I believe the dog was on the couch. Somebody let the dog on the couch. That's an inference. That's really not the observation. The observation was the dog hair on the couch. So those are two different things. And when we're doing labs, we do both. We make observations and we make inferences, and we have to understand which is which. So let's take a look at a simpler way to talk about those two things. These are the examples that I would recommend you write in your notes. An observation is a measurement that we take using our five senses. We see something, we hear something. You could taste something, although we don't generally taste anything in the lab. That's dangerous. But if you're in a cooking laboratory, you would. We might smell something. When our five senses are involved, you touch something and see the texture of it, whether it's warm or cold. Those are observations. We're taking that information in through our five senses. An inference happens in our brain and in our thinking. It's a guess that we make based on our observations. So let's look at a couple of examples. If you look at this picture, what are you observing? See if you can think of, you don't have to write them down for me, but you might want to jot some things down on a scrap piece of paper. See if you can think of an observation and an inference about the picture here. So let's look at some of the responses, and keep in mind you can always pause an Edpuzzle if you want to spend some more time on one part. So common things that I see people say is that the sky's dark, that there are no people, and that the clouds are present, the dark clouds are present in the picture. Those are observations. When I hear someone say, it's going to rain, it's going to storm, it's getting late, it's getting dark just because of the time of the day, the boaters took shelter, those are things that we're deciding based on what we saw. Those are our inferences. And they're both very important in the laboratory work that we do. We just have to make sure that we can identify when we say something, is it an observation or is it an inference? Here's another example. Make a list of some observations that you can make about this picture. And then make another list and make some inferences about that picture. You can pause while you do that. So let's look at some of the common answers that I see when we do this activity. That thing on her head, it's like a pink hot water bottle. It's a pink, we used to call them hot water bottles, but you can put ice in them, an ice pack. That's something that we're observing. It's there in the picture. The green cup is there in the picture. She has a headache. Are we seeing that with our eyes? Or did we decide based on what we're seeing that she has a headache? She has a headache as an inference, not an observation. The blanket. You say she's feeling very cold. That's an inference. Why did we make the inference that she's feeling very cold? Because we can see the blanket. The blanket is the observation. She's cold. is our inference based on that. She's holding a phone, an old-fashioned phone. We can see that. We can make an inference that she's calling a doctor or calling out sick. She has a frown. We can see that in the drawing. She's sick. That's our inference. She's unhappy. That's our inference based on what we saw. So when we look at things, again, in the laboratory, we're going to be making both observations and inferences. We're going to learn to put our observations in our data. That's going to be in our data tables when we talk about what did we really see, what measurements did we take. Our inferences are going to be in our conclusions. What did we decide that means? When we observe things in the lab, then we're going to make inferences about what that means. And when we support, you've probably done things in science before where you support your conclusion with the evidence. Well, the evidence goes back to our observations. Our conclusions are where we're making inferences based on those observations. And it's just very important that we keep them separate. So again, observations come from our senses. Inferences are coming from our thoughts. And of course, there's other things we could think of why that person looked the way they did with the blanket and the cup. Maybe they were acting. Maybe it's an actress playing on a commercial or in a movie. Who knows? So when we talk about measurements, the other two important vocabulary words that we need right away are the two kinds of measurements. Observations, remember, they are measurements. But we make qualitative measurements and we make quantitative measurements. Look at the two words. They're very similar. It's not that difficult to keep these two words apart and separate from each other. If you don't pay close attention, you'll mix these words up forever. Okay? But you don't have to. They're easy words. Look at these two words, qualitative, quantitative. The difference in the words is that L and the N. And a qualitative measurement is a measurement that we make that does not include any numbers. And if you think about the L in the word, we can use that as the word like, as our memory device to keep this straight, which is which. A qualitative measurement explains what something is like. It uses descriptive words like it's blue, it's green, it's hot, it's cold. She's taller than her little sister. He's older than his cousin. None of those have words, but they are measurements, they're observations. Quantitative measurement has the N in it, and that N, we want to remember, stands for numbers. A quantitative measurement is a measurement that has a number. The basketball player is 6'4". The apple weighs 0.3 pounds. If it has a number, it's a quantitative measurement. That's something you want to keep track of. That should probably go in your notes. You can pause the video at any time. Here's some more details and reminders. Quantitative data is what we would write down when we're making quantitative measurements. So they would look like these, 46.5 milliliters of liquid in a test tube. The mass, we'll be talking a lot about mass, of the substance, copper carbonate there, is 21.23 milligrams. Those are quantitative measurements. On the right, this solution smells like roses. We're describing it using qualitative words. We're talking about what it's like, but there's no numbers. Again, something about these two words should be in your notes because you're going to use those words right away. What is the difference between qualitative measurements and quantitative measurements and the data that we get from them? Qualitative with the L in the word, descriptions, colors, how does it smell? Quantitative will always have a number. What kinds of things do we measure quantitatively? The temperature, the time, the decibels of sound, all kinds of things we can measure quantitatively, and we also do a lot of that in the lab. But we also measure qualitative things as well. So there's two kinds of measurements, qualitative, quantitative, and we want to be able to keep that straight. Take a look at these measurements and identify whether it is quantitative, qualitative, or not a measurement at all. Four vocabulary words that we just covered. Make sure you have something in your notes about them so that you can reference that, because we're going to hit the ground running with those words right away. Have a great day.